Home Factory. We get ready to mix things up a little.
And we flip the page on a homework essential.
Then we slurp up the story on straws.
But first, we follow the paper trail.
There's something different in here.
I know. I got my hair cut.
No, I mean the room. It's so elegant.
Must be the wallpaper.
That must be it. I wonder why it makes such a difference.
Well, to find out, we're headed to York Wall Covering's 336,000 square foot facility in York, Pennsylvania.
This factory opened in 1895. Did you know it's haunted?
But we do have a very old building.
Yeah.
And old equipment, and, you know, you hear strange noises from time to time.
Yeah, but I assure you, they're not ghosts.
But father and daughter duo Carl and Ashley do believe in wallpaper.
We love wallpaper.
Yeah, well, we do, and you can really express yourself.
Today, we're expressing ourselves with York Wall Covering's calabash design. First, the base color, or ground, has to be applied to unpainted wallpaper.
The paper is called substrate. For calabash, we're using a heavier stock since it needs to hold up a pattern.
The substrate runs through this machine, which rolls the grayish-green paint onto the paper.
But before they print too much, a sample of the paper goes to Bob for the first quality check. He's, what would you say you are, Bob?
I'm a bit of a color specialist.
Bob is checking to make sure the ground color is an exact match to the original samples.
And as you can see, it does look pretty good. And I think we're going to go ahead with this.
Excellent. The rest of the roll runs through the grounder machine and is hung on racks to dry.
Now, is it just me, or does this machine look kind of old?
Yeah.
We have machinery all the way back from the 1800s to modern-day digital machines.
This is York Wall Covering's surface print machine because calabash is a raised print design.
It has a lofted textural feel where it doesn't just look dimensional, it is dimensional, and it's made to look that hand-painted, hand craftsmanship.
And it's done with these beautiful engraved cylinders.
The cylinders are attached to the printer with these wicked-looking gears and screws. Cool.
Then, metallic paint is poured into the trays.
This is Scott, and he's a printer.
What are you doing here, Scott?
Now we're getting ready to set up a print. We have to tweak it, make sure it's raised prints coming off good enough, high enough.
Okay, well, let's get going then.
Okay, now we're ready to roll.
A back roller picks up the paint from the trays and pushes it against the engraved cylinder. The cylinder rolls against the paper as it is pulled past, printing the calabash design. But before they print the whole roll, it's time for quality check number 2.
Scott cuts off a sample and heads to a very well-lit room to move paper around.
Do you think he knows we're waiting on him?
Shh, don't distract him. He's got to make sure the pattern matches perfectly.
When Scott is satisfied, finally, the rest of the paper goes through the printing rollers and is hung up again to dry.
The drying room is heated to 100 degrees Celsius.
In the course of the lifetime of the company, we've probably made so much wall coverings you could wrap it around the globe 4 times.
Maybe 5.
Maybe 6. When the paper is dry, it's wound up into a giant roll.
That thing is huge. How are they going to move it anywhere? Oh, that seems logical. Yeah.
The roll is taken to the trimming machine, which is run by Larry, a man with serious style.
Ahoy there!
What are you up to, Captain?
As long as it's not the testing wall again. Oh, no. Why is there so much quality control here?
All our jobs are quality control. If they don't pass the quality inspection, anybody can shut the operation down.
Larry, buddy, come on, man. We have a show to do. Just give us a sign. Does the pattern match? Does the pattern match?
It's good enough to go.
Finally. The unprinted ends are trimmed off the wallpaper, and then it's wound up yet again on a roller.
I think you're getting a little wound up.
Listen, I'll ignore that. The roll is then taken for its final layer. This is Dennis, and he sure loves pouring liquids.
Okay, so hey, Dennis, has anyone ever called you Dennis the Menace?
No, I'm called Scooby
Why?
because I look like Shaggy.
Huh?
Ever seen the ghost?
No. Shaggy Scooby Dennis runs the printed wallpaper through the machine to coat it in a protective glaze.
It protects the inks from messes, scrubs, anything you do to it.
After the final layer has dried, the giant rolls are taken to packaging. A machine winds, measures, and cuts the paper into standard rolls for sale. The rolls are individually wrapped and boxed.
Then it's ready to be sold to anyone who wants to add a touch of class to their homes.
When people walk into a room, they wonder, why does this room feel so good? It feels warm and cozy and friendly. And the reason it's because it's wallpapered. It's not because it's painted, without a doubt.
You know, they're right. This room does feel warm, cozy, and friendly.
Yeah, I just hope the York wall covering's ghost doesn't come home with the paper.
You just had to say that. Ooh. Hey.
Behold, the Vitamix blender. Vita meaning life, mix meaning, mix.
Yep, leave these wizards alone with a whole bunch of delicious fruit and veg, and within seconds, a scrumptious smoothie emerges.
They also make terrific margaritas.
Yeah, I knew there was something I liked about them.
Oh, yeah. This is Vitamix's 175,000 square foot facility in Strongsville, Ohio. This is Anthony Scipio, Vitamix's COO. This is Brad Johnson, Vitamix's operations manager. Actually, who is this?
Oh, get a Vitamix machine, my dear people.
This is Vitamix founder, Papa Barnard. He started making blenders in 1937.
Papa Barnard had a great vision to improve the health and vitality of people's lives.
He also had a great vision to make us all feel really good about ourselves.
Without health, you're a miserable failure.
So with those inspiring words ringing in our ears, let's make a blender. Question, how long will this take?
That's a great question.
Thank you.
So it approximately takes 15 minutes to make a blender from start to finish.
Great. A Vitamix blender is made of 3 main parts: a base, the blades, and a container.
So let's start with the pre-made plastic case, which gets wrapped with an AC cord.
Every year, Vitamix uses over 40,000 kilometers of cord, enough to stretch the length of over 350,000 football fields.
Next, a 1,400-watt motor is dropped into the black plastic housing and is screwed and wired into place.
This motor uses the same amount of electricity as 23 light bulbs. The blender brain goes in next. That's a control board, which is prepped and bolted into place.
The bottom of the blender is encased in a shiny red shell, and the control switches are fixed and wired.
I'm going to call your attention to the business end of the machine.
Also known as the blades. They run at 37,000 RPMs.
Yeah, not only that, the blades move so fast they can actually generate heat. So the Vitamix can warm your soup while it's blending.
That's some 21st century technology right there.
That same technology and name is...
Nah.
Someone's sending a fax.
Yeah.
Hate it when that happens.
Well, at least the blades are cutting edge at Vitamix.
Washers, hardened stainless steel blades, and acorn nuts are screwed together. These guys are making about 5,000 a day.
Trays of assembled blades are tightened by a robot, and then transported to the third and final stage of the blender build, the container.
The container is made from food-safe, BPA-free plastic, and each year, Vitamix gets through nearly 2,000 tons of it.
It takes a factory worker about 30 seconds to screw in the blades. And then, the blenders are off to meet Livette and Julio.
The what now?
Wow.
Okay, so let's try to imagine what that might sound like.
Wow.
Excellent. What that means in practice is that these guys listen to and look at the blenders and can tell whether they're put together properly.
I can tell right away. I have an ear for the blades.
I am a tiger, like they say.
Finished wow-worthy blenders are sent to packaging, where they're boxed and weighed.
This handy scale can tell if a box is missing any components down to the tiniest screw.
So that healthy blenders can churn out healthy smoothies, healthy soups, healthy juices,
And
margaritas.
Margaritas are definitely a favorite for Vitamix.
indeed they are. Even Papa let his hair down every now and again.
To cool it, throw in your ice cubes, right out of your refrigerator.
Okay, let's reel this back in. The blenders are packed in shipping cartons, palletized and stored, ready for distribution to healthy homes nationwide.
And to margarita fans.
Well, yes, but this is just a smoothie.
It is until I add tequila.
And time for a commercial break.
The 5-star wire-bound notebook. The perfect canvas for my creative endeavors.
Yeah, the 5-star wire-bound notebook. The perfect canvas for my paper airplanes.
Yeah, okay. Well, this is ACO brand's 600,000 square foot facility in Alexandria, Pennsylvania. And this is VP of Marketing, Kelly Whittlefield. She's here to tell us of the high-minded academic uses one might find for a 5-star notebook.
You know, paper airplanes for sure, spit wads, and even, you know, hand-lettered band flyers.
Sure. Or, you know, for a discourse on the deconstruction of the feminist ideal in a postmodernist reality.
Lots of doodles, all kinds of doodles.
Well, people have been doodling on notebooks like these since 1867.
Notebooks started in the marketplace as a replacement for slates, for tablets that students used in the classroom.
The 5-star notebook itself has been around for 30 years and doesn't look like it's going anywhere anytime soon.
Annually, we make over 36 million of the 5-star notebooks here domestically in the U.S. That's a lot of notebooks. It's a lot of paper.
25,000 rolls of paper, in fact. The rolls weigh 1 ton apiece and arrive on these trucks.
That's right. The notebooks get made on one enormous machine. It's called the Belomatic 3549. And it's so imposing that it's supervised by 2 people.
These 2 people, Bob and Zane.
Now, we're not sure which one is the boss, but I guess that will depend on who we chat to first.
In which case, meet Zane, the boss.
Yeah, I'm Bob's boss.
Zane's responsible for loading the paper rolls into the machine using these hydraulic arms.
Each roll is spliced to the one before it using sticky back plastic to make one continuous sheet of paper moving through the machine.
Well, let's ask Zane how fast he can do it.
I don't know, maybe 2.5 minutes, maybe.
2.5 minutes?
I'm thinking.
Okay, go!
Oh.
Awesome! The paper travels through a series of rollers at a speed of 150 meters per minute.
First up, these rubber rollers, which ink the paper with red and blue lines for writing.
And Bob looks after this part of the machine.
We do about 60 books a minute. How many lines a minute, I don't know.
Right, Bob, of course, the guy who's not the boss.
Read between the lines.
Okay, well, once Bob's lines have been added, the paper moves through these pizza cutters,
which perforate the paper so that it can be easily torn out. You know, in case you wanted to make like a paper airplane.
Then the paper moves through a rotary blade, which cuts it into strips. Each strip is 4 notebooks wide and is guillotined to separate out the individual books. Holes are punched, which will eventually accommodate the wire coil.
But first, the covers. They're cut to size separately by a machine which makes this deeply satisfying noise. And again. Time for one more?
And we're done with covers. The back and front covers are hole punched and added to the books. Then it's time for the coil, which is made from nylon-coated tin wire.
Okay, so the nylon-coated thin wire, what you can't believe is before it's coiled, it's over 6 feet long.
Bob thinks it's pretty special, too.
Put the lid on it, and that's book. It keeps the snags on your shirt or your sweater.
The completed notebooks are stacked, stacked again, paraded under a flag of the USA, and head for the packaging department.
But not before passing by Bonnie. And what's your job, Bonnie?
I'm the boss of this section.
Yeah, you and everyone else, apparently. And how many notebooks are we making here?
We make around 70 to 72,000 a day in this section.
The notebook stacks are pushed into packing cartons.
Which are sealed bottom and top. Then headed to palletization to be wrapped, stored, and sent to students across the country.
High school students going to go between usually 8 to 10 over the course of the year. There are a few that will use less.
Us!
And there'll be some students that will use more.
Not us.
But 8 to 10 is the average.
You know, that's a lot of paper airplanes.
Tell you who loved making paper airplanes? Mark Twain. And he wrote the best fan mail to the company in 1884.
So Mark Twain, he writes, "Dear sirs, your pockets are an unspeakable convenience. They make authorship a pastime."
Yep, these notebooks are helping authors in homes across the world. So before you send that text, stop, think. Wouldn't a handwritten note be so much more personal?
Yeah, and you could even send it on the back of a paper airplane.
Yeah, you had to ruin it, didn't you? Okay, that is the last straw.
No, it isn't. There's lots of them.
You're right, there are. Hey, you ever thought about why people even use straws?
Well, I'm thinking about it now. So we're headed to R&M Plastic's 35,000 square foot facility in Barrie, Ontario to find out.
This is Dan Ritchie, general manager, and his dad, Bob Ritchie, president of R&M. So, Dan, Bob, why do people like to use straws?
Well, we can't tell you that.
Okay, is it because most people suck?
I don't know if I want to say what would our lawyers say about that.
Well, there has to be some reason.
Everyone looks fantastic drinking with a straw.
Okay, we can go with that. But what makes you two experts on straws, huh?
R&M's a third-generation company.
If you want a straw that's a unique color, a unique size, it's got a printed wrapper onto it, you need to be with us.
Okay, and with that kind of expertise, it's no surprise that 750,000 straws come off the line every day. That's 5 million straws each week. Stacked on top of each other, that many straws would reach halfway to the moon.
Today, we're investigating the simple drinking straw, and it all begins with polypropylene pellets.
Yeah, polypropylene is a kind of plastic that can be molded into objects. It's perfect for making straws because it doesn't absorb water, it's lightweight, and very flexible. The pellets are transferred to this portable tote. This is Jerry. He's going to tell us everything there is to know about making straws, right?
I might have to hurt you if I tell you too many things.
Yikes. Okay. Maybe just tell us what you're doing now.
This is part of the color mixing, actually. So this is where I add the color additive into the virgin material to make it the proper pigment for the customer.
And since we're making red drinking straws, Jerry adds 3 scoops, or 340 grams, of red plastic pellets.
And next, the mixer is turned up to 10,000 RPM. Oh, yeah. Look at it go.
That would be it for that.
Okay, so what's next?
And this is the part that really sucks.
Oh, man, I wanted to use that line.
Too bad. The mix of pellets and coloring is sucked up into a hopper and then dropped into an extruder where it's heated to over 200 degrees Celsius. And here's where the magic happens. This is Kevin, and he's going to tell us what happens inside the extruder.
In this machine here, we have this screw. It pulls plastic down, forces it up front, heating it. As it goes out the end, then we hit the nozzle, and it becomes a straw.
Impressive.
Hey, we're not just screwing around here.
And it mixes it together and melts it and blends it together into this almost like a lava-like substance, but not anywhere near as hot. At that point, it gets pushed out of a die at the end of the machine.
A die is a bit like a mold. It acts like the end of a toothpaste tube, forming the plastic into a straw as it's pushed through the end.
After that, it goes into a vacuum chamber that sucks it out and sizes it to our specific size that we want.
The soft and still warm plastic is pulled through a tank of cold water. The water cools the plastic down, setting it in its shape.
The water looks so clean.
It's clean enough that you could reach in and you could drink the water out of it at any time.
At the far end of the water tank, a haul-off machine grabs the plastic tube and pushes it into the cutter.
Each straw is measured and cut at 10 inches.
Quick, how many centimeters is that?
25. Nailed it. The newly formed and perfectly measured straws fall onto a conveyor belt.
This is Lydia, and she's in charge of the straws after they're cut.
This job got me grasping at straws.
Ah, clever. Lydia has to check the straws and move them into the wrapping hopper.
If she can keep up, this machine can spit out about 800 straws per minute. That's a lot of work.
It is. Sometimes I'm really sweaty. I'm like, oh my God.
The wrapping machine individually wraps each straw in plastic film and then heat seals it. Lydia does a final quality check as she bags the wrapped straws and packages them in boxes.
The boxes are taken to the warehouse for storage, ready to be shipped out and sold to anyone who wants to enjoy a nice, refreshing drink at home.
Wow! So, is there anything left to say?
Our straws suck.
Darn it. I hate when somebody beats me to an obvious pun.
Aw, there. Here, have some juice.